Yeah. So basically, how knowledge graph can helpful in data sciences. Now, as I told you and I showed you, the knowledge graph is the way to represent the knowledge, to represent the information in a structured way. For knowledge representation, we need a tool, and we are using the knowledge graph as a tool in data science, in artificial like organization, modeling of the data in a more better understanding way, reduce the searching time. For example, everyone is using the Google, and if you're writing a question, what is the capital of India? Nowadays, you can get a direct answer, New Delhi. But it was not in old Googles. You can get a document, you need to read it, you need to extract the correct answer. But because nowadays, since 2012, Amit Singhal and Google has announced that it is using Google Knowledge Graph. A knowledge graph term has been taken by them. Although it was not new, it was available, people are working with, but knowledge graph term has introduced by them at 2012, and they have introduced it to present the data in a structured way by using knowledge graph to model the data and to provide this type of things like organization. Knowledge graph organizes data from multiple sources and connect it with framework called organizing principle. So how it organizing the data? It organizing the data in the form of triples. A teacher teaching a student. So there are what are the triples? Can you tell me? What are the triples in this sentence? A teacher teaching a student. Teacher is a subject, teaching is a predicate, student is an object. So how these three things are related? An entity related with another entity with a relationship. Teaching is a relationship. So this is the idea behind the knowledge graph, to relate to, and this is a graph. If we talk, like if you make this thing like this will be a graph like this. This will be entity, this will be entity, and they both how they are related with the teaching relationship. This is teacher, this is student. This is one graph with one triple, only one triple. But when teacher has name, there will be another information, another triple. And so organization, representation, you can understand in the graph better than to read a document, and you can save the time also. When you are reading a paper like a 10 pages paper, it is very difficult to read that. Suppose you need to read this book and you have to start. But analysis, knowledge graphs enables advanced analytic reasoning, visualization and search. You can see as a graph, searching can be done, recommendation can be generated, integration, knowledge graph help integrate data from different sources. And it is not necessary that you are taking from only one source. It can come from any source. Just need to convert in the triple form and connect with the graph. Then context. Knowledge graph add context to data-driven AI techniques like machine learning. Machine learning are used to extraction of the information so that it can be speed up the process to get the triples. Then intelligent system. They can enable intelligent system for scientists and engineers. Right now, you are saying that several chatbots, even large language model by using the chat GPT, and there are so many. Every university, every organization have a small chat. But may I help you? May I help you? They can be made more intelligent with the chatbot because they are giving the question answering facility. If you know, may I help you? You can ask with them question. Either it is hotel reservation, booking.com, or everywhere. So they can work as an intelligent system to provide the accurate information that you require by reducing the time, searching time. Such examples of how knowledge graphs are used. So generally you all are using Google, everyone using Google. Bing, X and Yahoo use KGs, knowledge graph. They have this technology behind their organization. Question answering services, Wolfram Alpha, Apple, Siri and Amazon, Alexa and use KGs. Sometimes I have if you remember Alexa advertisement, Alexa, please run this, please this. So we are talking with a system, with a model. We are giving the instruction and it is following the instruction. So how it is following the instructions? Because of the modeling of data in a knowledgeable way. Right? Then social network. I hope you all have either LinkedIn or Facebook and you are using it. You remember when you are connecting one person, it is giving the suggestion to another person. Either it can be your family member or it can be your official colleagues or anyone who is connected with you. So how it is recommended? While it was not earlier at the beginning phase, if you remember, this facility was not about there. But nowadays, it is giving the suggestion that you can connect with them. You can people you may know them. This type of things are there. So it comes by the knowledge graph, because behind there a knowledge graph working. Behind there is a graph technology is working. People are connected with their information and somehow they are related. If my brother is connect on the Facebook and I am on the, so some entities, some features will be common with both of us. If my colleague is working, so some features will be common, like institution name, like our parents' name. So with these features, with this semantic knowledge, semantic description, every entity is connected with another entity and then it can give the suggestion that you can connect with that. Right? So there is involvement of semantics. This is called semantics. When your information is not stored only like a key term, it is stored with its meaning, that who is, suppose tank, there is a word tank, there is a word jaguar. Jaguar can be an animal, jaguar can be a vehicle, but both of things, both entities have different features. Animal will have different legs, tail, heart, but vehicle had engine, churches and everything, other information like so. But if you search jaguar only, then maybe you can get all kind of jaguar, animal, vehicle. Now you have to spend your time, you have to find what information you are requiring. But if there is only, you get the categorized. You want to go animal, you want to go vehicle. You are searching for vehicle, so you will go vehicle directly. No need to go in animal. So your time is reducing. And how it comes? It comes with its semantic description. Behind knowledge graph, semantic description work. Semantic, what is semantic description? If I am storing my information, Sanju Tiwari. So maybe there will be many Sanju Tiwari, maybe some male people, mostly male people have Sanju Tiwari, Sanju name. Not Sanju name is really hardly you will get in the female name. So but if my description will be stored as a female, as a professor, as a daughter, as a friend, so this called semantic description. Every entity will be stored with its own features, with its own information, so that reduce the ambiguity, repetition, and it will have a unique representation of every entity, and then it will connect with the correct entities. So this was the idea behind this RDP that we are going to learn, because maybe the techniques will be new for you, but the idea is not new. Idea is helpful for all kind of sciences here. So and then scientific research. Knowledge graphs are used in genomics, proteomics and system biology. They also can be used to understand customers by linking their interaction and preferences. Keep this point, I will show you in my presentation how it is helping to customer. Like, I will give you example. If you recall earlier 2002-03 Google, if you use old Google and search like one so you will get the portal, they are giving the suggestion to book the car, right? So it is improving the business also. Some people require the travel vehicle also along with the hotel, so they can easily book. Customer is also benefited and organization also benefited. So these are the things that how it is helping. We will come in the slide. It was just an introduction. So now, what is knowledge graph? So, data without relationship, has very little context, no meaning in that. If there are some data, I am telling you that this hotel, this class, this, but how they are interconnected? If they have no relationship, there is no meaning of interconnection. There is no graph. So it is necessary. You can see that this diagram, there are entities are given a scattered form. There is no relation. But here you can see they are somehow related, like in a way. But here not described, connected, but how they are connected with each other. What is the relationship? Here you can understand that T is an entity of teacher, S is an entity of student, and how they are related, teaching relationship. We can understand that the teacher or the student have a relationship of teaching, but machine cannot understand. Keep in mind. Machine cannot understand who is Jaguar and who is vehicle or animal. So everything is going to make machine actionable data, machine understandable data behind the knowledge graph. Is right? So there should be the now. Here you can see that data is available when it is not related, it is in terms of data. It is available here. Then relationship makes a graph. If there is relationship, you can present in a form of graph, that is called a dynamic context. If it has semantics, you can identify the meaning of the context. Knowledge graph, deep dynamic context. What is the context behind this? How one sentence is presented in a form of graph, and then how it is connected in another graph. So this is the base that how it is maintaining behind during the modeling of the knowledge graph. So you can see here there is a one sentence, which genes regulate which pathways. So this is a query. Here it is creating gene regulates pathway. This is a relationship, one relationship, and this is written in the Neo4j. Have you heard the name of Neo4j? How many aware about the Neo4j? Okay, yeah, okay. So basically, what is the Neo4j?
What's basically we just use it as query this thing to.
Yeah, we just need Neo4j is the easiest way to learn to create the knowledge graph, because you will get sample of videos, you will get sample, but it doesn't have yet any standard, and but it is easy and it is very easily available open source Neo4j database. You can create your entity, you can relate them, but here I am going to and this is called property graph. Basically, knowledge graph categorized in two: semantic graph and property graph. So property graph, Neo4j supporting property graph, and semantic graph supporting to the not knowledge graph is two types: property graph and semantic graph. So Neo4j is for property graph, and RDF, OWL web ontology language, that has a W3C standard. It is accepted by WW World Wide Web Consortium, and it has a particular language. So this helps to model semantic graphs. So I will cover here semantic graphs in deep, because Neo4j and property graph you can get on the web. That is very easy. So I need not to take the to share you the easy thing. You will do this. You are masters. So now, graph data sciences answer the big questions. So behind the knowledge graph, there is a graph technology that helps to answer the big complex queries. And graph data science uses relationship to answer critical questions: what's important, what's unusual, what's going to happen next. I'm not going in deep in this, but source is there and you can find out. Next, these are some graph technology. Maybe you have heard some of you have used them. So path finding and search, that is the main technique behind the graph. The path, creating the path and shortest path. Then there are many algorithm, case spanning tree, random walk, minimum weight spanning tree that we are studying in the data structure, that is come from there. The same thing in advanced form. Centrality, these are other algorithm. Community detection, graph embedding, similarity, heuristic, LP, and these are different. I just included here. I'm not going to explain because I also not working in all the algorithm. So if you are going to work, you can find this type of algorithm. You can use the best one. Machine learning pipeline. How machine learning help you? So when we have the label data, pairs of nodes that are either linked or not. What is the label data? That data is there, entity is there, either it is connected or not. Pre-existing attributes, algorithms, embeddings provide the labeling data, and this called node classification. That what the first thing, finding the node. Second thing, labeling the node. What will be the label? What will be the in which category? Like T, who will be the teacher? Who will connected with this entity and who will connected with the student entity. So this is kind of node classification. And then property regression. What is property? Property is just relationship that I am continuously explaining that there should be a relationship to form the triples. So this is the main thing that teaching this called a property. So you can find that finding the property to relate the node. And then link prediction. When we are getting the text, like there is a paragraph, there is a structured text. So now you have extracted the entities. Now there is the thing that you have to find the relationship how these nodes will be related with each other. This is the link prediction. And machine learning can be helpful in all, like finding the node classification, which term will be node, how these nodes will be related with another node. So machine learning here helping in the information extraction. Although need to check accuracy because sometimes there is fault results, so graph can be disturbed. Now, after graph, we are coming on the semantic. Because semantic description, semantic representation is the key behind the creating the graph. So, started from synonym, taxonomy, thesaurus, ontology. You have already heard these names. They formed in as a hierarchy, different hierarchy. Till here, you can found thesaurus provide the synonyms. A medical term can have different terms but representing two same person, like a doctor, an oncologist. Oncologist also a doctor. So this type things will come in the synonym. So in this way, some botanical name and some general name representing same flower. So, but one term is new here, ontology. What is ontology? Have you heard anyone? Ontology. Basically, ontology is a Greek word to organize the entities in a conceptualized form, classify them, relate them. And the base before I told in the first slide that knowledge graph term introduced in 2012. Right. So what it is called before 2012? That was ontology. And still ontology behind the semantic knowledge graph. Is still ontology working behind semantic graph. This is also called, you can get, is it duster? Can I remove this?
Yes. Good.
Thank you. Okay, so where we are? Yeah. If you are getting RDF graph, it is also referred to ontology. If you are getting semantic model, this is also referred to ontology. So do not need to confuse. There are different terms, but they refer to the ontology. Ontological model, that is conceptualization of data in a different way with its meaning, providing its meaning and reducing the ambiguity, providing the reusability. If one entity has been defined once, you need not to define again and again. And it will have a particular address. So it provides entity resolution analysis, classification, tagging, and by using nowadays by using artificial intelligence techniques like machine learning techniques for making for extraction of data, and I will explain you in the next slide. So I am running a winter school on knowledge graph and semantic web these days evening online although. So just one of the speaker Neha Keshan has very well explained about the semantics, and I took this diagram here. She is a assistant professor in RPI USA in Cedar Polytechnic Institute. So semantics come from an ancient Greek term semantikos, meaning significant, is the study of reference meaning or truth, representing the data with its meaning. That is called it is called a way of ontology. I will ask the question the last after this slide. Okay? So be ready. So knowledge graphs, an ambiguous graph with a limited set of relations used to label the ages that encodes the provenance, especially justification and attribution of the assumptions. So in databases, now I am taking the example of databases. So because when I will compare with the database, you will get it very easy. In databases, what are available? How to make last bench? Can you tell me? In databases, what things are there? Have you created any table? Last bench, not first bench. Tell me, come on. What is available in databases?
The information about.
The database is formed as a row and column. We call it schema. We call it schema. And schema is created by the rows tuples. Tuples, attributes, right? But it is fixed. And you can understand that this is X, Y, Z is a teacher. Machine cannot understand. You cannot use the same table in different places, right? If you created one entity, you cannot use everywhere. In every register, in every table, you have to recreate it. You can use join the table, but you cannot reuse the entity. It is hard. But here, the schema is also in the ontology. Ontology at the schema level, where we are creating the structure of table. But when we are putting the data, populating the information, that is called knowledge graph. So this is the comes knowledge. What comes in ontology? Schema. And what comes? KGs? The data. Information. Entities information. Instances that cannot be categorized further. Right? Like if I am teacher, there can be multiple teachers in an organization. Teacher can be classified in further, but Sanju Tiwari is only one. It cannot be categorized further. It is an instance of teacher. So when we are creating the schema, that is comes under the ontology. When we are populating the information, that comes under the knowledge graph. But today's everything called as knowledge graph because knowledge graph comes from ontology. Right? So here you can see city, Paris, capital of city, France. So city, Paris, Paris is an attribute, an instance of city, and how it is connected with France. France is a country. So they are instances. France is an instance of country, Paris is an instance of city. Is it clear? So now, what is a graph? Again. So we are playing the graph and graph and graph. So I am just trying to make it easy so that you will not get bored. What is a graph? We send email to people so they will visit our website and buy our product. This is a sentence and you can see how this sentence has been created in a graph. Last bench I will give you some sentences and you will create a graph today. So see here, what is a graph? Graph is a visual abstraction that describes how different things are connected. So I think after this explanation you can understand this that very easily that how this graph and this graph is more meaningful to explain this sentence, right? And in that another graph you can see now here you can see it is highlighted what is the node, what is the relationship. In the previous graph you can see your sentence is a form of graph. But in this graph, you can see it has semantics, which are nodes, which are relationships. That machine can also process the data. When we are providing as node and when we are providing the relationship. So semantics is here. You can see graph are composed of nodes plus relationship. So I hope you will not forget it. That what is the graph? In some short definition that you can say they composed of nodes plus relationship, and nodes represent entities while relationship link to these entities. Node, these all yellow part is nodes and red part is relationship. That also called the edges, node and edges. You can find somewhere some term edges also. Right? So these are some use cases where graph can be used. Customer 360, recommendation engine, marketing attribution, enterprise search, fraud detection, master data management, supply chain, geolocation, access and asset control, social network, IT and network management. So this was, and then this was the semantic representation, and this representation is in Neo4j 12. You can see here that this graph has been created with the cipher query. This is a cipher query that is behind the Neo4j, because this slide is from Neo4j, so they have used their own product. But I will explain semantic graph. So here you can see that this is node, this is node, this is node, this is node. And you can see person P is entity, the website is an entity, entity means node, product is an entity, and email will be also there. Yeah, email is also there. They have created the email. Send to is a relationship, and there is a different structure to create the relationship. Then sold on is also relationship, visited is also relationship, purchased is also relationship, and they are using different style to create the node and create the relationship. So this query is very easy to understand, that email sent to person, full name Steve Newman, who visited website, sold on product and purchased this. So in this way graph is connected with each entity by using the cipher query. Is it clear to us? So all entities are connected with the relationship, right? Any query, brilliant?
Yes.
Any query? Okay. Is it fine? So these are some examples. You can see they have jumped to the, they have moved to knowledge graph, but they born in the graph, that is they are using, they like LinkedIn, Uber, they are using previously a graph technique behind this. So it was the introduction of the graph, knowledge graph ontology. Now I am some use cases showing on the sustainability, how sustainability knowledge graph are useful here, and then I will come to the main point that what techniques are there, how we will use, you will use if you want to create a knowledge graph, right? So quickly, this is a sustained graph. That is, sustained graph is created by European team for the sustainability development goals, and this is, they have claimed, I am not that this is the first graph on sustainable development graph, knowledge graph. So you can go in their, they have the paper also. Yeah, there is a paper that you can go. Sustained graph, a knowledge graph for tracking the process and the interlinking among the sustainable development goals target. This is a research paper. I will share you the link. So basically they have provided that data comes from CSV, data comes from policy documents, social media input, data from OpenAI's, KPI with UN SDG data, images, satellite, citizen. That I told you in the previous slide that how data knowledge graph can be built from different data sources, not only from particular one data source that you are taking from CSV or some. No, here you can see policies documents, social media input, KPI with UN SDG and other, right? So, and how they are connected, relationship among data. Then the first step to find the data, the second step to relate them, the third step to provide them semantic. This is the way to create a knowledge graph. So first you have found data silos. Data is, you can see data is in this form but not connected. Here you can see data is connected but no meaning how they are connected. Here you can see semantic alignment, add semantic description. SDG description is based on UN Sustain SDG ontology. So that's why I have introduced you the ontology term, because every knowledge graph will have the ontology behind this. Now you can see here the schema is coming from the SDG ontology, right? And then ask question and get answer considering the semantics of each node and relationship. That is called the data interoperability. How you interoperate with your knowledge graph. Any user can make any kind of query under this domain, because this is a domain specific knowledge graph. What is this? This is a domain specific, general knowledge graph, domain specific knowledge graph, like LinkedIn, social knowledge graph. So Google is a general knowledge graph that is available for all. And then identify new relationship and patterns. If my relationship with my brother is already feed in a model, and we have a sister also, but we did not connect it, it automatically connected. Give that, if you run a query, how many siblings, it will give. Why? Because our features, my brother features are same as that entity. And if the features are same as that entity, that means it also a sibling. So you can see identify new relationship and patterns to show the hidden knowledge, to show the hidden relationship. That comes from the knowledge graph that automatically identify, but in databases you cannot identify this, right? In databases you can structure your data, you can model your data, but you cannot generate automatic hidden relationship. You cannot perform this kind of reasoning, question answering, right? Because this question is always come. Now, what is sustained graph? So, sustained graph is an open source project that aims to develop a software platform for measuring and visualizing the sustainability of various systems such as organizations, supply chains, and cities. It has modeled this type of information And who has created Eleni Fotopoulou and her team members have modeled this, and there is a lot of data around these sustainability goals. The data is stored in various data silos in different formats and semantics with little. Actually, there are so much data is available on sustainability, but she is claimed that it is not or either very little interoperable data in a structured format. So if you the team is achieving this by taking advantage of the power of graph databases and the exploitation of natural language processing and machine learning. So these techniques are using behind this graph that is available for data population, knowledge production and analysis. This is a conceptual view of this sustained graph, that how they have managed the entities and how they have related them. So you can see there are goals is another entity and some other goals. All entities are somehow interconnected with another entity. And this is one schema level, not information level. Instances are not. This is a conceptualized form of the schema level. That can say ontology. Right? Okay. So that was the sustained graph. There is another graph for ESG, knowledge graph. So this is also published in one paper. Knowledge graph added LLM based ESG question answering from news. So this is for environment, social and graph. Environment, social and governance problems. So ESG stands for environment, social, governance, and they have modeled the related information and extracted from news. That is the available data. And they have prepared this. The schema you can see this just to make aware. And there is another one, co-plant ontology, basically. So you can search it. There are some. They have created this ontology based on this requirement. So core concept for the companion planting decision support, different types of companion and anti-companion relationship, define properties describing various mechanisms, describe qualities of optimal and suboptimal garden configuration, model specific plant species and their metadata. What is metadata?
Data which contains another data. Information about data.
Exactly. In that I am telling attributes. So metadata is attribute. Like my features is the metadata. Features of this book, who wrote, when published, this is the metadata information. Right? So this ontology is developed and guided by the methodology that is previously accepted and provided to create any ontology. There are some methodology are suggested, and if you did not mention that which methodology you have followed, it will be not accepted by the community. That when there are guidelines, methodology, so you need to mention that which methodology you have followed. So these are some use cases in the sustainability. This is the conceptualization. You can see categorized core classes and relationships, then companion types and many more, hierarchical basis. But there are relationships that perform reasoning. How you can extract the hidden information or relevant information that you require. So it was the overview that what is the knowledge graph, how it is used in general life, how it is applicable in sustainability, what are the use cases available in sustainability that are already accepted and well developed. So now I am coming at the technical part. So you can say that I am going to start this technical part from this slide. Okay, because now whatever I will explain, you will understand well. How technically we will design the ontology, publish them. So basically, as we know all aware about the artificial intelligence, there are several branches: machine learning, deep learning, natural language processing, robotics, knowledge representation, and many more. image processing and all, computer vision. So this part is come under the knowledge representation. How to represent the knowledge, how to manage the knowledge, how to model the knowledge. This comes under the knowledge representation. You all need to read if you require to read. Boris, one of the person who presented this blog on LinkedIn, so you can find out about this. So first of all, what does the World Wide Web do?
It's connected all.
Yeah, and now I am going with the zero from scratch. So, World Wide Web, yeah, you are right, that to connected people, entities, places, that was presented by Sir Tim Berners-Lee for the content web, but the first version, Web 1.0, that content web shopping cart, and it was static, not dynamic. Only for the static pages were there. If you are searching something, the page will come. That's it. Visualization. Because it was behind the HTML that you can make static pages. Then Web 2.0, the social web like Facebook and YouTube to make interactive. And then 3.0, the main thing is here. You can see in Web 3.0. Rest all the things you know, how they are improved. But this is important that involves semantics in the Web 3.0. And they have extended the version of World Wide Web and termed it as semantic web. What it terms? Semantic web. Why they have extended the version? So they have extended the version to improve the limitations of World Wide Web HTML. What was the HTML limitations? They are HTML www based from the www, and it is a system of in fact interlinked hypertext document. It focuses on the document, not data. Web of document, while semantic web is web of data. So it is a network of pages of text, images, sound, internet, which can be viewed by using a browser. Right? Links document to document by using the HTML code and pure web of document. Okay? Content is human readable but not machine processable. Machine cannot disambiguate who is the vehicle jaguar and who is the animal jaguar. In this, that was they were lacking for the semantic description, so that machine cannot differentiate between the entities. Then HTML lacks of standardization, incompatibility between the browsers, incompatibilities, and also lacks of expressivity because metadata information was not there. Right? So all terms are same. Then not sufficient to express the semantics, and the main thing, you cannot perform reasoning over there. You cannot make the query answer. And then semantic web over World Wide Web. So semantic evolved in 2001 and semantic web was launched as an extension of the World Wide Web to provide a transparent, open and decentralized internet represented data, not only documents. Merged in different concepts, you can get linked data, open data, fair data, knowledge graphs as represented as web of data. Is it clear? These terms are always related with the semantic web. So, the classical web, the World Wide Web was a classical web. It is the study of the structure of science system focusing on the form, not the meaning in the World Wide Web. In semantic web, it is the main aspect to design semantic web to provide the meaning expressed in language and other system of science, so that every machine can understand what is the jaguar vehicle and who is the jaguar animal. Is it clear? teeny, and they have several recommendations such as RDF, Resource Description Framework Schema, Web Ontology Language, then extension of Web Ontology Language out to Sparkle is a query, SQOS, SWRL, rule, these are the rule languages, and shapes also the rule language, and many more. So if you will go, I have included here all the terms under the semantic web. They comes under the semantic web and they follow the W3C standard. The best thing of that. Allows sharing and interaction between heterogeneous data sources, strong reasoning ability of logical inferences. So this was the ontology. That's why we use the ontology. Now, differences between ontology and databases. That I already explained during the explanation, but you can see here more clear. Ontology focuses on meaning, databases focuses on data. Syntax of ontology is based on logics, description logics, first order logics, and while databases are based on ER, UML, you can see. Strong focus on semantics, minimal focus on semantics. Expressed by, ontology are expressed by hierarchy, class, subclasses, properties, individual means instances like person is an entity, teacher is an entity, but Sanju, Tiwari is an instance, is an individual. Triples, rules are all comes under the axioms. While in databases, expressed by entities, attributes, relations, and constraints. So, reuse if possible. Ontology, the beauty of ontology, the beauty of semantic web, the reusability, to follow the FAIR principle, findable, accessible, interoperable, reusability. That's why ontology and knowledge graph here to implement the FAIR principle, FAIR, findability, accessibility, interoperability, and reusability. These 4 terms. But still in databases, one table cannot be used in another table. However, you can join 2 tables but cannot reuse. Okay? So this is the difference. Now I hope you will clear about the databases and ontology. That why we should use ontology. This is a very big question. I always stuck in during my PhD because I was totally new, not has deep knowledge about that. And when I go anywhere present my paper, I had very good paper. But when they are people asking starting, what is ontology? Why we use ontology? Then I had done another research. First of all, I should know the scratch to satisfy the query. If I am not able to satisfy your query, it doesn't make sense to be present a big paper. So, but as a researcher, when you are beginning, these problems always comes. But then I find out to explain it, and I always starting to ontology. I had learned this lesson that if I am going to give anywhere a talk, I need to clear first of all these terms because they make an interest to learn why we should use. So, defining ontologies, Gruber 1993 has defined ontology with a single definition in a very good way, that is formal explicit specification of a shared conceptualization. So, what is formal, what is specification? Machine readability with computational semantics. This is called formal and explicit specification. Why we are doing everything? So that machine can accessible, machine can understand the main idea. Then explicit, unique representation, unambiguous terminology. If one time you define a person, you need not to define many times because it will have an address on the web and you can directly use that address. I will show you how. Then shared, reusability, commonly accepted understanding. You can reuse it. It can be shared to anywhere. And conceptual model. The hierarchical form. First of all, you can see it everywhere. as a conceptual model, which are classes, which are subclasses, what is the relationship between both of them. So this is very nicely represented by him to understand what is ontology in the definition. Now, this is a very good example by Samir Tatir, and they have presented this structure. I always use this figure because it is very easy to explain the schema box, P box, A box, and you can understand here, like this is the schema box, and here you can see writing. Writing is a class that has two, essay and novel are the type of writing. Then you can see historical essay is a kind of essay, historical novel has both, can be both type of, right? They are the entities, classes are the entities. And now you can see how it is related with another entity. So in this schema you can see writing has no any label here, but person has a label here. What it means? Can you explain? Anyone can interpret this? What is it is mean? FOAF dash person. I mean, do not go what is FOAF, but what is the way? Why they have used this?
That's main they can analogy is the main reason we should use that. So in database we can't reuse that.
Exactly.
Yes.
So that means this person entity is already available somewhere in FOAF schema, and we are using here. So we need to give the reference of that particular schema. So this is the difference, that this is their own terms, but this is used from another one to implement the reusability, because person is already available in several ontologies are there. FOAF is friend of a friend. Ontology already defined earlier. BBPDI is also there. So they are, you can use anyone. Now you can see this arrow is showing the is a relationship, that B2 is a historical essay and name of B2 is Willem Civil. Right? Now here you can say B1 and so on. There P1, P2. There are number of author name as P1, P2. The idea behind this, you can see this entity is related with this entity. Writing, translator can be person, author can be person, and writing can be used for the translator. Writing can be done by the author, right? And how they are related? So domain is translator, writing. Writing, translator, person. This is a triple relationship. And writing by author will be a person. So this way relate the triples. But here you can say they are all kind of entities. While here in this box you can see they are all instances. So this is a schema box, P box, that is called terminology box, that you are making the terminology. And here instances box, that is A box, attribute box, axiom box, you can interpret. So this is categorized, this is the structure of ontology, that when you create it will form like this. Is it clear? Okay. These are some already available, you can open if you are working on the system. So disease ontology, as a semantic model you can see how ontology is represented graphically, visually. Snow city, they are well accepted by the biototal and biological ontology, and they are used in live projects. This is very old ontology. So you can search, if you have opened you can see cancer, gene. If you will type the here, you will get like this type of structure with its metadata information like this. And the same here, you can find the details, you can find the visualization, mappings and everything. So these are available ontologies that are available and used. So now, semantic modeling of data. Meaning of data within the context of its interrelationship, machine readability, well-defined schemata, semantic express and intended meaning of data, explicit semantic is missing in many structured resources. So, I think not difficult. So this is here. Can we say this is a semantic model? How many support that is? We can say it is a semantic model. Is it a semantic model? No? Very good. Yes?
No.
How many says yes? And how many says no? Only one. Okay. And rest are neutral. Okay. No, yes, no. So, no. Because it is a table. It is a database. And I told you that database cannot be a semantic model. And semantic model is an ontology. So, why? Because can you reuse this entity? No? Right? Can you categorize? Machine understand what is the name? Machine can process. What is the designation? Machine can process case? No. Exactly. Machine cannot understand what is the name. For it, Rama is a person or Rama is a dog. It doesn't matter for machine. But here you can say name. Person has name. Person has age. Person has location. Right? No, it doesn't matter, but if I will not use, you can present this hierarchy class form that I have categorized in the previous exam of disease ontology. But this is the best way to explain, to differentiate. If I will show you taxonomy, then relationship, to show the relationship, it will be difficult to explain. But always when you are working on the software, you will get it as a form of hierarchy. Right? So you can see that a person has its attribute. So machine can understand that this is a person. Why? Because it has these features. Right? So this is a semantic model. We can say that this is a semantic model. Why? Because person has name string Rama, well-defined schemata. That is the property of ontology. So person has age integer 40. Right? Person has location, entity to entity relationship. Right? So this is a domain specific, and one of my project that where I my students work under my guidance, and they have created a knowledge graph for Astra. Astra means weapons. So I put the Hindi name. So here you can say, if you run a query, can you find out the name of writer who wrote the book Wings of Fire? Yeah, suppose there is a query. Find the birthplace of the writer of Wings of Fire. So there are two queries. Because this is a complex query, it is easy to find out the writer of Wings of Fire. But it is complex to find the birthplace of the writer of Wings of Fire. Why? Because still not you will get the writer, the name writer. First you need to get the writer of Wings of Fire, then you need to get the birthplace. And it should be modeled over there. So here you can see that what is the Wings of Fire? It is defined book. Who is the writer of? What is where he is born? And it is an area. Rameshwaram can be anything, college, place, city, but non-living thing also. But here it has an area, that means it will be, it is specified. And who is the creator of Nag, Agni, when they were launched, and what are they Nag, Agni? They are missiles. So in this figure, the data is modeled like that, and when you perform a query, you can get the direct answer. Is it clear, maybe?
Yes.
When we have worked in 2021, we remember, this information was not available in Google. But I think now if you will write this query, Google is giving, because it is working well in the knowledge graph and connected all the entities. Day by day, knowledge graph are populating more, including more entities. So, giving good answers. So, languages. These are the languages that are used to define the ontology. RDF, RDFS, OWL, DML, OIL. Basically, these are used. Resource description framework is schema, and web ontology language. That is the extension of XML. And tools to edit ontologies: Protege, Soup, Apollo. Protege is open source tool. You can download it, freely available. You can create your ontology over there, a simple ontology. I will go in the hands-on session after this, and I will suggest you to create a small ontology. Till then, you can apply to Protege download because it will take few minutes. So, query language: Sparkle, SWRL, Rule ML. This is fixed for semantic web. Sparkle is a standard language that is only used to make the reasoning. Reasoners, Pellet, Hermit, Fact, they are available already in the Protege. You need not to go and find out, but you need to understand that what techniques to run for the query. Reasoners are there to execute your reasoning.
In answer session.
So, what are the RDF and RDFS? As I shared in the previous slide, that HTML concentrating layout, XML concentrating on the content. Both presentation, but what was the similarity between both of them? HTML and XML both are working for the documents only, not for data. Right? So here you can see no association among different resources. That was the main limitation. That two entities cannot be linked. And presenting only perspective aspect, not descriptive aspect. Here you can describe your entity with its metadata, connect with another entity, reuse another entity, and perform your query according to your model data. RDF is an extension over HTML and XML. Then it is presented as triplet forms. That is triples. From where we have started, now come over there. Right? Then strong relationship between two resources. For machine under. We know, if we are seeing that teacher term, that means teacher who taught us. But machine doesn't know. Machine will know it when we will tell it. Then how they are formed: subject, property, object. Right? SPO. Are object property value or value property value. These three kind of triples can be generated here. Now, like doctor treats patient, SPO, person has age, object property value, right? David has age 24. Here you can say this is a value, this is a value. So value property value relationship, right? Here you can see object property and this is a value. Is it clear? More clear, to define a professor, Oscar Corcho. He is a professor in where I have done my postdoc, and he is expert of this semantic web ontologies. In fact, this team was involved to develop the semantic web. And you can see, if you have, he has a link over here, like in this way. If you create any individual, any instance, any entity, it will have a particular link here. And now it has name Oscar Corcho, it has title doctor, role professor, role PI. Now machine can understand that this is a person. Why the metadata information is going for person, not a dog, not a thing, not a place. Because a place will have different attributes. A pet will have a different attribute. Okay? So, RDF and RDFS extract syntax, formal semantics, graphical formalism to describe semantic relations between resources, sharing of taxonomies and vocabularies, different serialization. You can download it XML, Turtle, different serialization format. And query language is Sparkle. When you are resources in a form of resources, that Oscar Corcho is a professor, PS David is a PhD student, David, Paula, Shaurya, they are the PhD student of Oscar.
Please.
Oscar is a supervisor of
David.
David. Oscar is supervisor of Paul. So this type of relations are already explained, and these are also explained, and this provides the reasoning how you perform, like who is the, if you are performing a query, who is the supervisor of Paula. So in this, when this model, then this information will be modeled in this way, then it will be easy to extract the information from these triples. They comes under the triple generation. So logic, what provide? It provides powerful formalism to represent classes of object and their properties in form of ontologies, sharing of ontologies, logical inferences over data, defining rules over data, powerful reasoning framework based on description logics. The base of OWL is from description logics. Now, this is a paper of Oscar Carcho with their supervisors, and they have proposed some methodologies that I already shared you. When we are creating any ontology, we need to specify which methodology we have followed. So there are different methodologies: Rodinger, Renshaw, Bernares, Sensors, onto knowledge, meth ontology. These are different tools. Protege is one of the tools that is commonly available as an open source, and you can see these are the different languages. You are aware of OWL, RDF, and we will cover today here. Not all languages, but web ontology language, that is OWL, OWL, and RDF and RDF. But this is the base. If you are starting to plan, you should understand these things. So now, from ontologies to knowledge graph again. From ontologies to knowledge graphs, right? Because knowledge graph we have started. What are knowledge graph in general terms, then technical term, and now I am relating that from ontologies to knowledge graph. So this is the way that taxonomy, control list, taxonomy, ontology come till ontology, that how we make the relationship, and then how transform into knowledge graph. So capture related data, integration of structured data, unstructured information, link data store, and also model to enable machine learning and AI capabilities, drive efficient and intelligent data and information management solution. That is the aim from after then ontology to knowledge graph. So knowledge graph was termed as third era of AI, like first era considered as procedural era, where raw data and procedural rules make the programs answers and with explanation. In the second era, machine learning era, it was the machine learning era. It was still that raw data answer machine learning along with the millions of rules, right? Then the third era called as knowledge graph era, raw data along with machine learning, creating the graph, providing the knowledge, answer and explanation. These all, so that this is called knowledge graph era. Now, this diagram, what it explains, there is two terms, ME27. This no understand, but here, what is ME? Machine is failed to understand here. Machine is fast to understand here. Why? Because ME is named 27 is age. Now it is providing the information. Very good paper here in knowledge graph. I put the source. This is also Man Kejriwal from University of Southern California, and he explained well that data is available in this form, data is available in UML form, but hard to understand about the particular specific data. But this is easy to provide the human readability, structured and in the form of structured data, right? So knowledge graph, there is what is now I am explaining the technical term, increasing attention from both academia and industry by Google in 2012, and it enables machine to better organize, reason, understand and explain the information. Some well-known general-purpose knowledge graphs like DBpedia, Yago, Freebase, Wikidata, and the Chinese linked open data effort. You can find out, you can check. linguistic knowledge graph, WordNet, BabelNet, and linguistic LLOD, open data. These are some existing available big large knowledge graph for different purposes.
Yes.
So, who was the one? Singhal has announced the knowledge graph things not string by Google. And Lisa Wolfram has given another definition that knowledge graph requires and integrates information into ontology and applies a reasoner to derive the hidden knowledge, new knowledge. Kingsley, they are different people. Some academicians, some industry people. Knowledge graphs are a collection of entities, entity types, and entity relationship types that manifest as an intelligible web of data informed by an ontology. And these are the sources. This is again, you can see a schema and entity description. This is the terminology box and this is the entity description A box that I have take the diagram and explain. In that example is same as example of that use of fire. It is how it is related with the ontology. How information is contained in the ontology then populated with the instances. And these are some definitions, other definitions from different organizations. These are some knowledge graphs, popular knowledge graphs. Year wise you can say 2012 knowledge graph, 15 LinkedIn, Microsoft, Facebook, and Yahoo. And these are some academic sites: Wikipedia, Yahoo, Wikidata, Freebase. You can find out, you can explore them. But they are all available online. Now, the main thing that I had told you, the property graph and RDF graph, that was missing. So, property graph, that Neo4j, and RDF graph that you have studied now, ontology and everything. So, what is the difference between both of them? The main use property, traverse a graph, RDF, querying a graph. Particular purpose. This is for property graph for path analytics, social network analysis, while RDF graph for data integration, data modeling also done, and knowledge representation in well manner. Then the main problem with the property graph that other things can be achievable, but they do not have standard. If there is a condition to use technique that have a particular standard, then you cannot go with the property graph. But they have the W3C semantic web standard. And shortest, they are for shortest, smaller level scale knowledge graph. They are good for shortest path calculation. But RDF graph can go for inferencing at any scale. Resource description framework. So, now very good example, I hope you will like. I have found out this way to explain, although I have explained. So, this is the old Google, right? Buy bath soap online. You can get some documents here. No visualization, no any recommendation, no any suggestion here. You just get that statically some pages. You can extract the information over there. Now, another, this is the now today's Google. The same query put buy bath soap online. And you can see there are so many bath soap with their price, with their quality and everything. Right? So, search before knowledge graph. Okay? And search after knowledge graph. So, I don't think I need to explain anything here.
Can I say these knowledge graphs are the building blocks of ChatGPT or LLMs?
Yeah, they are reducing a but who will take the responsibility that this is the accurate response and who will evaluate? This is a question. Hallucination is there in the ChatGPT and yes, you can take help, but you need to be very careful that you are extracting what data. Is it true or not?
It's basically these are working on these.
No. ChatGPT now they are helping to integrate the knowledge graph, to model the knowledge graph. Like if you give some document and ask him provide its entities, so it will provide you entities, it will provide the relationship, but how much accuracy between this triple generation? That is a question. You need to be very clear if you are taking the LLM. But you cannot say that behind the LLM knowledge graph is working. No. LLM is the NLP based. It is providing natural language processing based data. It trained the billion trillion data and give the answer. Knowledge graph basically a model data to present the data, to store the data, just compare with the database. So you can see that writer names of in old Google, when we have searched writer name of Wings of Fire book, the query, and writer name of today's, you can see that you can get the direct answer in today's Google. These are the live examples that you can also try for another queries, that how it works without KG, without knowledge graph, because this is working on the old knowledge graph and this is with knowledge graph, current one. So now these are the knowledge graph application: keyword search, question answering, simple information needs, predictable search behavior, structured query, demand for absolute precision answer, specification of complex information, more automatic semantic. These are the general application. This is the how you create first data acquisition, feature extraction, connecting in the graph, providing the entity resolution and relationship, then providing the semantic and basic search. DAO-DB, anyone can, the user interface can be interact with the user. Interact with the knowledge graph. This is another way to construct the knowledge graph. I have taken different examples from different sources, like data ingestion, entity linking and merging, knowledge refinement, publishing and search. And this is a knowledge graph Astra created on Neo4j that I have talked in the previous. Here these type of queries like which launch platform uses missile manufactured by DRDO, and you can get the direct answer. That is not available to get exact answer of these queries on the Google. And this is also which missiles are manufactured by both DRDO and Bell Laboratories. Here is you can get only the document, but here in this model you can get the direct answer along with these other information: mini operating range, minimum operating range and maximum operating range of that particular missile. These are some challenges still, and this is already covered. Yeah, this is very important that for encoding ontology, you can see these tools are there: evaluation, these tools, visualization, these tools, publication, these tools. So for verification, you can use Themis, TTD Onto. They are the library include in the Themis is the online available, and TTD Onto is a library that can be included in Protege. And validation can be done on Protege and OOPS. There are two forms, and this is one of the smart healthcare ontology I will show you that is created by me and published online. This is the Protege window. Here you can get a Sparkle query that you are acquiring the patients who are related for the heart patient, and you are getting these are the patients who are the category of heart patient. So this type of Sparkle query is running. In hands-on, I will show you these things rather than this here. These are some related publications that I have published with this is a book, personal knowledge graph for user personal, like what is like my personal information, health information, so personal knowledge graph to store any particular to generate the recommendation alerts, like you have low BP, low sugar, so what time you have to take, and if it is not if the weather is not suitable to go outside, so it will assist you that how is the weather, can I go to outside, you can ask. And these are some running events that I am still running. Springer, I am the general chair of these conferences. Editorship, that is running. Editorship and guest editor in journal. Semantic Web Journal, iOS. I am also the associate editor of Engineering Application Artificial Intelligence. Just last month I have included in the top Q1 journal of Elsevier, EAAI. I forgot to include here. These are some supervision that Google Summer of Code Mentor and DB master student, PhD student and intern student. I am open to supervise any kind of student like intern student or something. These are some future directions that I am seeking the work in these type of area, neurosymbolic AI, sustainability network. This is the contact, although I am still here, but not last slide, so I am still. This is when I was in NIT Kurukshetra. This slide is very strong. There was a Hindi Divas, Hindi Day, and they are the DAD internship came from Germany. Because DAD providing for sending from Germany to India and India to Germany. So this is a related programs from any country to any country. And these two students came from there and they like our traditional. Yeah? Then I helped them and I asked that this is the best day where you can wear it. And they like it, they loved it. And finally, I have a very good collaboration with them. And I have an inspiration that I should also like, but I never thought that I will be the DAD scholarship. So after that, I got the DAD scholarship. This picture was 2015, 16, 17. But in June, in 2021, I got the scholarship of DAD, and but due to COVID, I couldn't go. And in June 2022, I have made this and visited 4 universities. This was the ORKG that I will explain you in the hands-on. I visited this group. He is Professor Zorain, University of Lübeck, University of Lufana, and DBpedia group. This is the DBpedia knowledge graph group who created the DBpedia knowledge graph at Leipzig, Germany, University of Leipzig. So 4 universities. This is Leibniz University at Hanover. This is Lübeck University at Germany. This is University of Lufana. So I am including this picture to motivate you that you can also do it. Because I never dreamed it. And these are in Knowledge Graph Semantic Web Conference. I am one of the chair of this conference. Last 5 years I am running. With the other collaborators, we were the chair at 2020 in Spain, Universidad Camilo Cosela in Madrid, capital of Spain. And we have successfully organized this conference. Last year I have visited 4 countries. In 2023, Germany, she was the Vice Chancellor. Mostly I wear our traditional in outside India. Although you will find it very rarely. But I am. And this was the Knowledge Graph Conference 2023. She is Deborah, Professor Deborah. She is one of the person from RPI, in Siller Polytechnic Institute, and one of the person with Tim Berners Lee group to introduce the semantic web and all. And I was the panel speaker in Indonesia at 20th Pacific Ring International Conference last year, November 15 to 19. And this, it was May in Greece. I am one of the text 2 kg from unstructured data to knowledge graph. I am running a workshop over there. So if anyone working, this year it is Slovenia in 2025, you all welcome to send your paper. Here in April 17 this year 2024, I have presented Digital Twins Landscape in India current status in Barcelona Digital Twin Congress. I was the one of the person to present India over there about the digital twin status, what is going on in India. And I have got the comment that when I have taken the names of trains, number of trains, 1,000, and number of buses and number of cities, smart cities, and they tell, because the digits are in thousands, more than 1,000 and all these, oh my God, they are gems. Wonderful. So it was really very good conference and well presented from here. And this is just visited in Vienna, Greece, Austria and Germany. the launching of this book that I have here, Open Research Knowledge book in Hanover. Then in Vienna, it is the United Nations. I was invited as a guest researcher, and then I had the chance to visit our flag under take the picture. So it was a pleasure. And the same workshop, Greece, in 2024 this year. Now this next year it will be in Slovenia. And this was the Vienna University where I was the researcher, invited as the researcher. So this was a trip. He is my son. Music, he's good in playing and singing in the music. Although now he is in 10th, it is the previous one. So thank you so much. I just included these pictures to motivate that I belonging from a very middle background. I was not an IITian, not a very top, but if you are getting the blank screen, that means your query is correct, but data is not modeled in that way, so you are not getting the proper result. But error should not come. Now I would like to show you a very interesting thing. Just a minute. That you should know, because the same way you can see the data properties, these were the object properties, right? And yeah. So these are things have you done. Now, but save your ontology again. So and go to the web browser and type there web wow, web owl without space, WE, and select the web-based visualization of ontology. Yes. Yeah, and you will come here, GitHub, and there is a link given. Did you get this page? Yes. Yes? Please help beside your done? Yes. Okay. Can you see this screen? Come to the GitHub, and on GitHub right side corner, you can get a link. Just click on that. Have you done this? Yes. Very good. This is very simple. Okay? Have you done? Yes. Now you will get this screen. Web wow. Now come to the down and put here or click the ontology. And down. Yes. You can see custom ontology, select ontology file. Click on the select ontology file. Yes. Can you get it? Yes. All of you? Yes. Now click on that. You will get this window. So go there where your ontology saved. Document. I think you have saved your ontology in the document. So go there and select from there your ontology. Got it? Yes. And upload. Have you uploaded? Have you uploaded? Yes. That's nice. Results always looks nice. What? Yeah, exactly. Happy? So this is your graph. But the problem is you have not connected all the entities. This is the problem here still. So you need to add more properties. Every node should be connected with another node. Otherwise, it doesn't make sense to have the node if it is not connected. It means it is not meaningful. But now you are in this capacity that you can do this work after, because it needs time. It needs time. So everyone have this graph? Yes. And now you can see, click on the node, you can explore and you can reduce the size. You can also plot this thing on your board. Why you left? Don't give up. Just open, it is very easy to do. So have you opened all of you the graph?
Yes, ma'am.
Very good. And you can move it in large, small, whatever you want. If you will click on particular node, you will get the information on the right side. Is it clear?
Yes.
So this is the visualization. This is the visualization. Now your ontology can be seen by everyone on this tool. It is not only for you. In Protege, it was only for you. In Protege, listen me. Do not stop your learning. Not finished yet. This was not the objective to show you your graph. Okay? They all have the graph and they all have maybe they are very hungry. Okay.
No, you said anybody else can see, no?
Yeah.
How you can see? How can you browser now?
Sorry?
I have said, you said anybody on the browser.
You need to upload over there. You need to make it public. You did not see. But in this way, you can make it public. Now, please see one more thing. Because I will not give about this in the next, because the next session, article discussion, we also have a lot of things. And this part is also over there. So, just one thing. So here you can see, this was my ontology that is here in the Protege. You can see healthcare concept, actor concept, you can see here, right? Healthcare devices, you can see actuator, RFID. Please, it is very important for you, right? So this thing is here, ontology, and now you can see that I have taken one link here that is in the presentation. There was a link. This is the link. You can see this. W3ID definition smart healthcare. You can see on the slide. And anyone can get this information and just paste on the net here. And you can get this ontology publicly available. You can see this page. So this is the FAIR principle and ontology publication that anyone can download it. You can see here JSON LD format, RDF XML format, and triples and turtle. Is it clear? Who has created, when it was created, and what is the name? Now you can see here the main important thing that I have told you. You can see actor. Actor is a class in the ontology. You can see here. Actor is a class. You can see. Actor is a class in this ontology. The same thing over there. And now you can see actor has its own URI that I told you that makes it unique. Now if you will create another actor, it will not accept and it doesn't make sense to make it again. Because actor is already available and you can use with this URI anywhere. You can see HTTPS and this blah blah blah. Every concept after publication, it has its own unique address. And by this address, like if you remember FOAF person, we have used FOAF. So you need to use this prefix of this ontology and you can anywhere you can use. This is the FAIR principle. Findable, accessible, interoperable and reusable. So how it can be interoperable? Now anyone can make query with this ontology. If you want to make a Sparkle query with this, directly you can take this reference of ontology and just put the query in Sparkle sample queries. You need not to make the another one, right? And here you can see the validate your ontology. Here you can load your ontology and you can validate it. You can see like sensor is a subclass of device. Is it true or not? You can check it. So, sensor sensors subclass of, you can see here relation is available there, devices. You can see like health devices concept are coming because ontology is already uploaded here. And now check, is it correct or not? Yes, passed. So that sensor is a subclass of health device and it is available in this ontology. The ontology that you have created, that is published, and if it is published, anyone can use it from anywhere. You can also use this link and you can run to check any concept that is available or not. So this is a validation. How your ontology is responsive. Concepts are available over there or not. Okay? Is it clear?
Yes, ma'am.
Okay, so this ontology is validated and I would like to show you that just 2-3 minutes more. I will not bother you. So you can see this has all metadata information. You need to be very careful. You need to annotation property and you have to define all the information of annotation property. Then it will be the meaningful. If your concept hasn't have a meaning, then it doesn't make sense to have it. Right? So annotation you have to do from here. And other information of properties are classes. You can provide from annotations. Every concept should be like what should be its label, what should be its definition, and that will be reflected here. When you will visualize it, you can see every concept, actor, definition of actor can perform a complete intervention and this. Every concept has its own definition. Actor is defined by this link. Actor has superclass of healthcare. Actor has subclasses. Actor domain is this. Actor range is this. So these all things should be described. This is called semantic description. Without this description, your task is incomplete. It is not easy to complete it in 1 hour, 2 hours because you have learned a lot of things. The main top level. Now, but I am explaining you to go with this, to explore more later on. Whenever you, if you have interest, if you want to do in this, you need to give more time. So thank you so much. I hope I will not take.
So 5 minutes, all of you come down and just check with ma'am. Please come for a short photography. Then we can have lunch.
Before that, I have an announcement. I have shared an article summary Word document with all of you. You have to edit that, and as a team, you have to create a separate document. And as a
Order of the classes is not important.
Done? All of you have done. Please do it quickly.
Totally 6 classes, no?
Huh?
Totally 6 classes.
I don't know because in the last one, you can see here active ontology. You can see your structure. How many total classes? I've done. All of you done? Because we need to, now I will move when you have done all. Okay, have you done? You both done? Yeah. So, now save it with a different name. Now And now you click in this, you can see there are different formats to save an ontology. Right? It is not necessary to save only OWL XML format. If you want turtle, you can get in turtle. If you want JSON, you can take in JSON, LaTeX and OVO format, Manchester. I explained that it is the flexibility of the ontology. Semantic web, you can get it in different formats. But while if you compare with the database, there is no way. If you have created a table, it will be always a table. Is it clear? So as of now, at this moment, you have to take OWL XML only. Right? And click OK. Is it clear? Now you go where you have saved this file and you can check the extension over there. File name. C drive, D drive, it will be saved somewhere. So go there and check it where it is. Because I have saved it, so I need not to check it. Where you have saved? Go that folder where you have saved. Did you get the file?
Yes, ma'am.
Where is it?
Documents.
If you get your file, right click on it, open with Notepad. Just open it with Notepad. Okay. So I think it is saving of the documents. You have to give a name of your ontology, okay, and now you have to give a name. Yeah, open with Notepad. Yeah, that's the code. Yeah, that's the code of ontology that you are seeing on prototype. Behind this code is working. But it is not easy to write manually. That's why we are doing from over here and it will automatically increase here. There is a code generating. Right? This is the OWL code. OWL XML. That I want to share you. Can you see your code? File code? Do you understand? This is just a tool. But actual thing is here. The language is here. Okay? Have you opened your code on Notepad? Okay? And where it is saved in document, you can say the extension will be OWL. Automatically because you have selected OWL XML. Is it clear to all?
Yes, ma'am.
Can you understand your file? What is in the format? Now, you did nothing yet. Because not a single class is connected to anyone. And if there is no linking, no meaning of semantic web. Okay? So now we are coming to the linking. And how we will make the linking with the entities? How we will link? Yeah, exactly. Very good. So, this triple generation. You have your entities. First of all, you have data. Now you have converted them into entity, classes, subclasses. You know that which will be the class, which will be the subclass. Now you have to form which class relate with which class. Then triple will be made. So the third step is triple generation, or you can say entity linking, right? So now come, and now it will be done by the object property and data property. Is it clear? So now you can see here, come to the object properties, right? So here there is a property affect. property.
We have to create
Yeah, click on the object properties. Click on the object properties,
Yes.
right? And create effects. Let me wait. I am still taking the screen and can you see this? So create these properties. Affect, causes, depends on, is part of, located in leisure. Right? Just create that add some property. Go to object property and click right in the class. The same method as you create the class. Right click here for new property. Click here for new property and click for the sibling on the same level. Right? Otherwise, if you click this again, it will be the subclass of that property. So you need not do subclassing of the property. You just need to create class, same level property.
Option is not highlighted here.
Click on your property. Click on the property. No, the screen, white screen. Yeah, click on this. Always click on the thing or the top level properties. Then you will get active the options. Done? Very good. All done? All done? Yes. Okay. Have you done? Okay, don't worry if you are not making all. You put at least 3 to 4 properties so can make the relations between both of them. Done? All properties done?
Yes.
Here? Done? Okay. So what object property is done? Relate to the entity to entity, not value. If you know that what, like you have to put person has age and it will be value, then you will use the data property. But here teacher is connecting with the student, both are the entities. Both are the entities, so this will be done by the object property. You need to be very clear about this, that what will be the entity, what will be the relationship, and relationship which kind of object or data. Is it clear?
Yes.
Okay, well. So, should I move? Okay. So, need to come here. Now you can see. I have selected this affect property and here need to fix domain and range. Connect with the entities. Like teacher is the domain and student is the range. Teacher teach whom? Students. Who will, I am teaching and you, for me, all of you are the student. Right? So these are two entities. So domain is teaching, range is student. To make machine understandable. Right? So now you need to go domain and click this plus option. Right side, you can see right side. Domain. See in the characteristics, description alerts. See this. Did you get it? Did you get it? Who didn't get? Yeah.
But okay is not
Huh?
okay, only cancel is coming.
Yeah, wait. No, you need not to do anything. You need not to do anything. Just find out the domain description.
Yes, ma'am.
Open the window. Okay, let's see what to do. If you click here, then you will get like this. If you are clicking here, object restriction creator. Come to object restriction creator from the box, because we are modeling object property. So we will select object, and now click here and you will get your same property. So this is the domain. This is the domain. Select it and it will be some here, and now go to the bottom and click on the OK. Sorry. Now here you have to select the sea level rise to whom this property you are going to connect. So here there was a sea level rise class. You can see. Come to the climate change impact. You have to select the class now. See, come to the top object property, select effects, then here in the side box you need to select class. Are you able to do? All of you? Are you able to do?
Yes.
No? Can you explain her? Can you explain? Domain, click on the domain. Can you please explain me? Because I am not able to support here. Sir, click on the domain.
Sea level rise.
Yes, because right here you have selected, see example this. Teaching you have your property, but teaching to whom connect? Teacher. So now first domain is sea level. No, domain effect is the property, but the property should be connected with some class. Sea level rise, right? And the range will be student here. So now you have to select the range. Click on the OK. If you will not do the OK, it will not be accepted. Done. And it will be written here. Yes. Have you done it?
Yes.
Domain fix? Okay. So now we are going to fix the range. Come to the range. And again come to the object restrictor. done this? No, just leave it now because it will take time. I would like to come now this way. You can see that classes are connected with another class. So this was the way to connect one class with another class, right? The same way you will come for the data properties, and data property like has value, temperature has value. That has value is a property and it can be related with precipitation, temperature. So temperature, like temperature has value this, precipitation has value this. So you have to fix the domain of the has value data property is temperature. Now make a data property has value. Have you done? Okay. And now relate with the domain, fix the domain and range. Temperature will be the domain. Yeah. Okay? Is it clear? And this is not only the way, it totally depends on your ideas. It totally depends on your requirement, how I have to link. Domain. You have to create this. Data property, you have to create this.
In class hierarchy, we
First on the left side, you have to
Now,
create
what
one.
is that?
Here.
Like you have create object properties. Now you have to create the data property.
What is
Has value.
class value?
Has value.
Has value.
Yeah.
Ma'am, in domains, the temperature have to connect with class hierarchy, no?
Temperature has value and value should be there something like it depends when you put the value 101 or something, but now you are specifying. No, they are object property. You need not to touch them. You have to go in the data property. You need to create it, data restrict. First you need to create the data property. Then, double. Yeah, if you created, then select the data restrictor and then select your property. That's it. And there are options like this. You use this one. Data restrictor, you have to go here. Data restrictor has value and from here you have to select some of them. Okay? Is it clear?
Which one we have to select? Which one we have to select, ma'am?
Double. Double. Double is the data type. Like integer. So maybe it will be in decimal. So I put it double. Because this will be a value. Okay? Have you done this? Now click on the orthograph. Now click on the orthograph. Did you click? Yes. And put the control S. Control S. I mean, you have to save your current data, that updates that you have made in your file. So, did you use the orthograph? Have you done this side, sir? Any problem? I can explain you. What is the problem? You have understand well. Okay, you can come that side and I can explain you. So Don't leave it. Yeah. Can you see this graph? Okay. All of you can see your ontology as a graph. Go to ontograph here. Go to ontograph. Right? And you can click on the boxes. The classes who have subclasses, they will have a plus. Just click on this, it will be spread out. Okay? Now, this was the visualization. This is ontology creation. Huh? Double click on it. And you take its screen by taking this camera. It can save this output. Different format you can use. Okay? Have you done? Is it clear?
Great for others.
Okay. So now come to the sparkle query. So here I have a problem that my screen is not supporting sparkle tab. I don't know why. But I hope your screen is supporting. Yes. And you will have a query also. Yeah. Now click on the execute. Click on the execute. Have you clicked? Yes. Click on the execute. Have you clicked on the execute? Are you getting something? Classes and subclasses. This is a very simple default Sparkle query. Yes, which is already given in this. Done? Okay, Sparkle is running.
Yes, ma'am.
You can run. You can try this Sparkle. Click on this Sparkle. No, but yeah. Click on this and execute this. Execute. You can get the classes and subclasses that you have modeled here. Classes and subclasses. So because objects are entities of particular class, so you can see them. Okay. So I can show you the next query. So you can see, you can write this query. Can you see this screen?
Yes.
Write this query. Only change the select part in your window. Only select the select part. Not touch the top prefixes. Do not delete the prefixes. And do not touch them. If you lost one prefix, you will not get the output. Just remove it or somewhere else copy it. Yeah, you just need to write this one. That one you can remove. The previous select query, you can extract and put somewhere else.
There is space after select space question mark or
Yes.
indicate?
No, no space. Question means extract this property. All of you can see this screen? Can you see? Can you see now? Yes.
And there is no indentation problem in this. Indentation is not required.
just see if somewhere dot, don't miss it. Like this dot, this dot, this dot, and this column. These are very important. And the braces, question mark. Because you are using the first time, but when you will be used multiple time, it will be very easy. You can do this also. It will run on your window. Just you can write this property. Only change the select part. Remove the select part and write this part, this query. Yes, this sparkle window. No. Just go on your sparkle window. This is the tab. Yes, sparkle window. How to do it? And replace this select with this.
Is it case sensitive?
Just first create this thing. Yeah. Just delete the beside. If you want to delete this cross button to delete this one. You need to understand for new class you have to click on this. For sub class you have to do this. Okay? Climate change drivers. It will automatically take if you are not.
After deforestation,
Greenhouse gas emissions. See, I am writing here.
changing the order.
It doesn't matter. Emission. Can you see now? Can you see now, back seat? Can you see now? How to? Come to the first of the class. No. Climb. And then click on the sibling class option button. This button. Organization is not the class of people. They are you make the subclasses. These are this one. Give the name. Climate change impact, global warming. See, one thing. See here, if you want to create a new class, you have, please be very clear. If you have to create new class, you have to click on this. If you have to create its sibling, you have to click on this. Like you have created urbanization, these three classes, and now you have to come back here, and then you have to click on this sibling one. Otherwise, if you will click here, it will go the sibling of that one. You have to come back again root. Right? And if there is a mistake, no worries, just delete it. So first, these are top level classes. Climate change, climate system, they are the top level. You have to come here. Then subclass.
Suppose I make a mistake. You can't click
Just
and drag.
remove it.
No, you can't click and drag.
Yeah, you can click it, you and drag. Just drag the class and drop on the where you are requiring. You can click on the class and you can drag anywhere. Like this, I am showing you in the screen. See, here see, like if it is a mistake, you want to take it, click on the urbanization and wherever you want to drop it, it can be moved.
Yeah.
Right? And then drop. Is it clear? So, yeah, it's fine. So now climate system, climate variables, ecosystem, they are the root level classes. Yeah, so that it will be easier to find when you are, if you do nothing have what to extract. And you will be flexible to create the classes and subclasses. Yes. This is the you have made all combinations. You need to include a subclass inside this. You just need to keep here. Right? And now you have made siblings. Maybe it's siblings. Right? So that one you can remove. Very good. Well done.
After coastal area.
Coastal areas. Okay. Climate system. After climate change impact, drivers first, impact second, climate. Yeah. Until when you are settling, you can go. You can go and sign it, but because you don't have any user ID. So this book is our first book on this platform, Open Research Knowledge Graph. And Professor Zoran Aoud is the director of Tiwari in University of Leipzig, Hanover. Who is the creator? Who is the father of this tool? So I will let you know that how you can, and it is not only for only computer science. Just keep in mind how I may think that you are from different streams, not only science. So you can see here how by research field. If you have to find the articles, if you find the research paper, you can see here arts and humanities, physical sciences and mathematics, social and behavioral. Engineering only have 4093. Have you registered? Okay, so you can open, after that you can log in on here. If you have registered, then you can log in. You sign? Have you done? So you can see if you are going to life sciences. Have you logged in? Yes. Everyone log in? Yes. What happened?
It's showing invalid character in my name.
Did you give the space?
No, I just gave my first name. In that
User ID only makes sense.
Okay, then you can click on the life sciences. So here you can see in life sciences there are number of variety categories are already categorized here. And it is very good to find a structured way published paper here rather than to search one by one. So you can see here like nutrition. If you are opening the nutrition, you can see that it also has some category and there are many comparisons like dietary pattern and obesity association. A particular category and then you can see like the comparison of the relationship between crop diversity and human dietary diversity. There is a topic based on a particular topic. You can found that this is a comparison and it is visualized, and what is inside I want to show you that you can see the papers are given in a comparison form. Literature review. Basically when you are conducting the literature review, you are comparing other works, and here you can see already idea graph to make your literature, to make your scholarly data in a structured form and available as per the FAIR principle. So only one link can give you 13 papers in this comparison, and they are compared for different properties you can see here. Right? And you can see that your paper is, you can see there are 13 papers, they are on the same theme. They have the same theme, common topic, and they are compared. So if you are going to work on this, you can easily get up and you can add more one to provide the latest research and reducing your task to define it from the beginning and or from scratch. So if you can find that some papers are missing, you can add, make a new one and prepare a comparison, and it will have a URL available anywhere. You just need to copy, and since long ago, it is saved in the document. No one has presented in the structured form that you can see your paper in a graph form. But Open Research Knowledge Graph is providing your article. If you want to save here, if you save your own paper, you can see in a visual graph form. How you can see? Just you can see this is a combination of many papers, 13 papers. But you can do, first you need to save your one paper. If you want to keep your paper here and you want that my paper should have a link so that anyone can see everywhere. So now you can see, you can click on a single paper here in this screen, and you can see that it is coming with the, you can see the graph by viewing graph. Now you can see your paper in the form of graph, and what it is taking, node, edges, relationship from the paper, and how it is categorizing the property that are feeded over there in that particular paper. Not only metadata information, inside the paper, what the paper has, that is encoded in the previous form. You can see here. You can see that this is a paper and these information are saved here. Correlation coefficient has beginning, has end, location, p-value, research problem, stand error, statistical method, variables, and these information are coming as a graph. Okay? So this is the idea behind ORK form. Click here if you don't have a GUI. If GUI is not there, you want to add by its paper name, title. So you just go click over there. Maybe it is already available, then it will tell that it is over there. And if it is not there, then you can add it.
Any format, PDF format also you can make.
You just paste here title, paper title here, and then you have to give the automatically get it. Generally put it save automatically, like give title. Yeah, you need to paper title, give research field, like if you are bio or something or whatever. Please automatically take the paper authors, but it's written off like taking. You just put one author and just go. Try to add. Have you done? Added? Very good. So here one more thing, ORKG ask. Now this is a new feature of this tool. You can ask a query, like you can find out a paper and it will give number of particular topic, number of papers it will provide you. So you can make a query over there. I am giving you overview the main things. Later on you can work on it and we can have another workshop or something on only on this, because it need at least one day to learn about. You can go with the title. Yeah, only title only I gave. I didn't give PDF. Okay.
Extension I
So
didn't
you
give.
need not to go. You put the title in DOI box.
Yeah.
That box.
UI box only I put.
No. In DOI box, you need to give only DOI. Then click on, if you don't need bottom down, there is a message. If you don't have DOI, then click over there. Okay. So I will suggest you to work on it, to get it structured form, literature review. This is really helpful to prepare your related work, literature review, to automate your research work, right? To present it in the structured format, and you can find out any kind of research papers that are available here already. So you can reuse them and merge with them your own content. And if you have any doubt, any query, feel free to ask about this. So this was the one thing that I had to share with you. Open research knowledge graph. Now, I will like to explain you article discussion. Some points are there, and then you can start. So, how to write a research paper? Types of research paper, outline of a research paper, guidelines for publication. So you can see research paper, why, what, and how. What is a research paper? Basically. So for students, for beginners, it is very important that they should know what is a research paper. Is a piece of academic writing that provides analysis, interpretation, and argument based on in-depth, independent research. When you have some work, implementing some work, and you want to share to the public, and you want that people read your work, so how can they access? You need to prepare as a research paper, publish it, and share to the community so that people can know that you have done your work, right? Research papers are similar to academic essays, but they are usually longer and more detailed assignment designed to assess not only writing skill but also skill in scholarly research. They have a different way to represent your findings as a research paper. And writing a research paper requires you to demonstrate a strong knowledge of your topic, engage with a variety of sources, and make an original contribution to the debate. Right? So this is the what, why, what, and how. So we will see in the next slide how to write a research paper. So what step you should follow? These are the basic steps. Maybe you can have some good steps, and I'm not telling that you have to be strict with these steps, but generally we prefer to follow in this way. That first of all, you have to find selection of research topic. Which research topic you have to select in your interest of area. It can be for any science, not only for computer science. So this is a main thing to find out a research topic. Then conducting review. What have been already done, and after doing, you are seeing that so many people already have done that work. Then it doesn't make sense to propose the same work. How your work should be different, it comes from this point, and this is very important point. This is the heart of the for the research, conducting a research, proposing a methodology, because generally people not taking it seriously. I have experience, but literature review part, related work part is nothing generally in the paper. If we are implementing something, we have a model something, that is everything. But I will say, and I bet it, as much as you will strong your literature review, your findings automatically will be strong. Because if you know what people have done and what are their limitations, what literature review provide? Literature review provide the gap, what already have been presented and what left to explore, to propose a new research. So first of all, whenever you are planning to write a paper, do not jump to write the methodology section that this is my methodology and this is my result. No. You have to know what you need to explore, which limitations are already available, and you have to solve them. Then you have to find out the problem statement. Then you can make a problem statement with that. So, conducting review provide you the gaps. Finding the research gaps, this is the third step, that what gaps you find in your literature review. If you have written papers like I have shown you in ORKG, 13 papers compared. Now you can sketch out, you can find out what are the gaps are there. Right? So, after these gaps, you can take one gap, not all gaps. There are so many limitations. So, you cannot cover all gaps, but you have to take one gap that is closer to your interest of area to frame the objective. Now, you have clear that what have been done, what you need to propose, what are the limitations. So, you have some problem statement that will come as an objective. Okay? Then, you can start the article. And after preparing the article, after preparing your manuscript, you need to find the venue where you have to publish. At what level your paper is deserved. I mean, you want to go for workshop, you want to go for conference, you want to go for book chapter, or you want to go for journal paper. So the level should be matched, and then you need to send over here. Without knowing proper information for the submission venue, you are submitting your paper, and after 3-4 months you are getting, without having any review, you are getting it returned. That paper is not up to the level of this journal, paper is not under the scope of this conference, paper is not any kind of, not pointing for the quality because it is not undergone to review. That is the secondary part. In first round it is out, but 3-4 months, can you get back those? Can you get back? No? So, to avoid this thing, you should be first do the homework, this type of. That where I am submitting the paper, it is relevant or not. So, these are the few steps. Now, so you can see here types of research paper. You also need to know which type of paper can be written. It is not necessary to always write like a scientific paper. Maybe it can be a case study, maybe it can be a tools and methodologies demo, or it can be a review paper. So, what is review paper? Present finding based on surveys on questionnaires distributed to a specific population. So, when you have decided to review on a specific particular topic and you want to know what has been done, what is existing and what is going on in this future, about this feature. So, you can go for the review paper. You are not going to implement something, you are not going to make a result oriented model, so that it generally comes under the review paper. A scientific paper is a written and published report describing original research result. It must be the first publication of original research. You have some mind, you find the gap that this model has some limitation and my model can recover this thing. So you are going to propose implement a methodology, a new algorithm, something like that. This can come under the scientific paper where you are finding the results that are not published previously. right? Then examine a single subject, organization or event in depth to explore its dynamics and implications, that are case studies. Okay? And then tools and methodology paper focus on the development, evaluation or application of specific tools, techniques or methodologies used in the research. And then these are few points for the types of research paper. And now outline of a research paper. Title page, abstract, introduction, related work, methods, results, discussion and conclusion. So basically it found in RAD format. Introduction, methods, result and discussion, basic format. But I include I have a query. From this is the outline. From which part you will start to write? To work.
Related works.
Yes, tell me.
Related works.
Exactly. Generally, we are seeing the title page, abstract, introduction, but this part is very important. And this is the first part. That you have to analyze the related work literature review. After then, you can find out your proposal. And after then, related work, you have to come on the methods. And when you have the result, these three things are parallel. First related work, second is methodology, and third is results. After then you have a clear picture what you have proposed, what you have result. Now you can write title, now you can write abstract. Abstract is just a short summary of introduction, and expanded form of abstract is called introduction. Then you can frame, and conclusion and discussion are also dependent on your results. So this is the way to write an article. And then guidelines for publication. So first of all, select the right publication venue. That is general scope, impact factor, indexing, and the most important thing is avoid predatory journals. How many of you knows about the predatory journal? Okay, thank you.
Yeah, what was mail that I have published one paper in some journal which I have not published.
Oh,
It's not up to me. Other authors also have sent a mail that we are not contributing in this.
so how it is published?
Might be a closed journal, but temporarily it will be visible.
This is also happening.
Yeah, there are so many frauds are going on. So you need the 1 minute Maggi noodles like cook. They are cooking. Submit today, publish tomorrow. So who will review your work? Who will evaluate? So please, because it kills the career. Once they have published, you requesting no one. There is no any responsible people to listen you are claiming, but they are not going to remove. And once it is available on the web, it give either you are innocent, you are not knowing about this, you are not part of that one. But sometimes it happens. I also have some bad experiences about this. So these things you need to be very careful. And guidelines, they are the journal finder tools. These are the Jane, Elsevier journal finder, Springer journal finder suggester. So you need to use them, and you can paste your abstract over there, and you can find where it is suitable to go, which type of it is suggesting the journals for related to your abstract. So this is very good thing to explore with this. Plagiarism check, Turnitin, Grammarly, authenticate. Always check your content. That is not if you have written in your own words, generally it has not comes, but you need to be very careful to check it. Referencing software, there are Zotero and Note mainly to manage your references, but I will suggest to go with Overleaf to write your proposals, your papers. Overleaf, it will automatically manage the references in Overleaf. So how to review a paper? This is also very important. After writing paper, you are at the stage to review other papers, and it is very good practice. When you are reviewing others' paper, you are knowing that what is going on currently and how they are doing their work. and where they are publishing, and slowly you can, I also started from a Scopus Index journal to review. Some professors have included me. They taught me how to review. I remember one time that I have submitted a review, wrong review to wrong paper, and I didn't see because I was a beginner and did not complete PhD. But slowly, when I did the mistakes, then I learned a lot that how to go and how to submit it. So this type of things are here when you are reviewing the paper. What is the problem being solved? Is it important? Relevant? Why? What is the prior work in this area? Maybe some has already published, and if some has already published, then what is the difference between both of them? And they will seated them or not? So, are the assumption and model reasonable? Does the paper address an important and novel problem? Is the methodology robust and replicable? Are the findings significant and well supported? Is the writing clear, concise and well organized? Does the paper contribute to the field? These points are important when you are going to review your paper. Not your paper, sorry. Review any paper that is assigned to you. And if you are interested to review, I have many venues where I can invite you as a reviewer. So most welcome to join. Okay, so these are the things. That's over from my side for the article discussion. That for article publication you can follow the ORKG for literature review, and for these guidelines can help you. And now there was that they suggested to have a presentation by team members to present their
What presentation? We have